Rust offers a rich variety of collection types that provide a way to store and retrieve data in an efficient and safe manner. Let's explore some of Rust's collection types. Rust collections all have different characteristics when it comes to use and performance. The most common collection type is a vector, which is a growable, continuous stack of items of the same type. For example, a vec of strings is a continuous collection of strings, and as we run our program, we can add and remove items from the vec. Next, there's a hash map, which offers an efficient way to store and retrieve keys and their associated values. For example, we can use a hash map to associate string keys representing people's names and values of type U8 representing their ages. We can then quickly retrieve people's ages based on their names. Next, there's a hash set, which, like a vec, is a collection of items, but the items in a hash set must be unique. Next, a vecdec is like a vec, but always allows for efficiently getting and setting items to the back and front of the collection, unlike vec, which stores new items always at the end. Lastly, there's linked list, which is a doubly linked list. Linked lists are much less often used in Rust than in other languages like C, so I'm only mentioning it for completeness' sake. There are other collections in the Rust standard library. Make sure to check out the docs to learn more about them. So when should you use each of these collections? Vecs are the most common and allow for accessing all the elements efficiently by index. This is usually the default choice when you just need to store items together. Hash maps are best when needing to associate some keys and values. And hash sets are great when you need the extra constraint that all items in the collection must be unique, and you don't need to access items by an index. Vecdecs are great for modeling queues, where you want to officially put items to one side of the queue and pop items off the other side. The docs have great explanations of when each collection might be worth using. Let's take a look at how vecs work up close. Here we've constructed a vec of U8s using the vec macro. We see the memory of the heap where this vec's items live. A vec is composed of 3 parts. First, a length, which is 3 in this case. Second, a capacity, which is the amount of room our vec is reserving for its items on the heap. The vec here has reserved space for 4 items. Once the 5th item is pushed onto the vec, it will automatically allocate more memory. Lastly, the vec has a pointer to its data. When dealing with a collection of items that live next to each other in memory, you often deal with a slice. Slices are references to items that live continuously in memory, and we write their type with an ampersand and the type of slices item surrounded by braces. For collection types that store their items directly next to each other in memory, it's trivial to turn them into slices. For example, vecs store all their items one after another in memory, so it's easy to turn a vec into a slice. We can turn the vec we created earlier into a slice using indexing notation. Here we're creating a slice that refers to just the first 2 items of the vec. The slice is composed of 2 parts, a length, in this case 2, and a data pointer. Remember, slices don't own their data, they just refer to other data owned by some other value. Now that we know the basics of what collections are, let's go ahead and use some of them.